Step outside on a clear day. Feel that warmth on your skin, that particular weight of light pressing against your face, that brightness that makes you squint even when you close your eyes. You have felt it thousands of times. You have never once thought about where it came from. Not really. You know the answer, of course. The sun, a star, 93 million miles away. You learned it in school, nodded, moved on. But knowing a fact and feeling a fact are two completely different things. So let's feel it. That light touching your face right now left the sun 8 minutes and 20 seconds ago. It traveled through absolute vacuum at 186,000 miles per second. It crossed the distance between two worlds without hitting a single thing. And the moment it arrived, it found you, standing in a yard, or on a sidewalk, or looking out a window. A small, warm animal on a small, wet rock, catching a photon that has been in motion since before you had breakfast. That is the relationship you have with the sun. That is what it is. Now consider this. The sun is not permanent. It has an age, the way you have an age. Right now, it is approximately 4.6 billion years old. Scientists know this because they can read the chemistry of ancient meteorites like tree rings, because the physics of stellar evolution is not guesswork. It is one of the most well-tested frameworks in all of science. The sun was born, the way all stars are born, from a collapsing cloud of gas and dust. It ignited. It has been burning ever since. And like everything that burns, it will one day stop. The question is not whether the sun will die. The question is what that death looks like, how long it takes, what it destroys on the way out, and what, if anything, is left when it is finally over. The answer is stranger, and more violent, and more quietly devastating than almost anything you have been taught. Because the sun does not simply switch off. It does not dim gradually like a bulb going out. It transforms. It expands. It consumes. It collapses. And before it reaches silence, it will have remade every single planet in this solar system, including the one you are standing on right now. You have approximately 5 billion years, give or take. But those 5 billion years are not smooth. They are not peaceful. They are a slow-motion catastrophe already in progress, and the first signs have already begun. The sun is getting brighter. Right now. Incrementally, almost imperceptibly, but measurably. Every 100 million years, and it increases its luminosity by roughly 1%. That does not sound like much, but 1% of a star is not 1% of a light bulb. The sun currently releases more energy every single second than all of humanity has produced in its entire history, combined. 1% of that, compounded across geological time, is the difference between an ocean and a desert, between a living planet and a scorched one. You are living in the sun's middle age, the relatively stable, relatively kind middle age. What comes after is something else entirely. Let's start with Mercury. Mercury is already the smallest planet in the solar system, smaller than some moons, stripped of its atmosphere long ago by the very solar wind it orbits too close to resist. It has craters that have never seen a shadow shift, because they sit at the poles and the sun's angle never quite reaches them. It is a world that is simultaneously roasted on one side and frozen on the other, a world of extremes that has persisted for billions of years in a kind of brutal equilibrium. That equilibrium ends first. In approximately 1 billion years, the sun's increasing brightness will have pushed enough energy into the inner solar system that Mercury's surface temperatures already reaching 800 degrees Fahrenheit on the day side, will become something no solid material can comfortably endure. More critically, the orbital mechanics begin to destabilize. Mercury's orbit is already the most eccentric of all the planets, already nudged by gravitational interactions with Jupiter and Venus over long timescales. Models suggest that within the next few billion years, there is a real, non-trivial chance that Mercury either falls into the Sun or gets ejected from the solar system entirely. Either way, it goes. Quietly, without ceremony, one fewer world. Meanwhile, something is happening to Earth that feels almost too slow to be called a catastrophe until you see the numbers laid out clearly. Right now, Earth sits in what scientists call the habitable zone, the region around a star where liquid water can exist on a planet's surface. It is not a fixed zone. It moves. As the sun brightens, that zone shifts outward, and the models show that within approximately 1 billion years, 1 billion, which sounds enormous until you realize life has existed on this planet for nearly 4 billion, the habitable zone's inner edge will have migrated past Earth's orbit. The oceans will begin to evaporate, not overnight, not in a century. But geologically, it is fast. Water vapor rises into the upper atmosphere. Ultraviolet light breaks the water molecules apart. The hydrogen escapes to space. And once that process begins, it does not reverse. There is no mechanism to bring it back. Earth becomes what Venus is today, a world wrapped in a thick, crushing, superheated atmosphere of carbon dioxide, its surface hidden under clouds of sulfuric acid, its temperature hot enough to melt lead. Sit with that for a moment. The planet that produced coral reefs and rainforests and the smell of rain on dry soil, gone. Not destroyed exactly, just transformed into something that would kill you in seconds if you stepped onto it. And this is still hundreds of millions of years before the sun enters its death phase. At around 5 billion years from now, the sun's core will have burned through most of its hydrogen fuel. This is the moment the real transformation begins. With less fusion happening at the core, the outward pressure weakens. Gravity begins to win. The core contracts, heats up under that compression, and that heat radiates outward into the surrounding shell of hydrogen, igniting it. The outer layers of the sun respond by expanding, not slowly. In stellar terms, rapidly. The sun will swell into what astronomers call a red giant, a classification that understates what is actually happening. At its maximum extent, the sun's radius will be approximately 200 times its current size. Right now, the sun is large enough that if it were placed at the center of the solar system and you drove a car at highway speed to its surface, it would take 176 years. At red giant maximum, and that same drive takes 35,000 years. That is the size of the thing coming for this solar system. Mercury will be swallowed first, simply absorbed, gone. Venus next. Earth is where the models diverge. Current best estimates suggest Earth's orbit will be inside or right at the surface of the expanded sun. Some models show it spiraling inward and being consumed. Others suggest the sun's mass loss as it expands, because a swelling star sheds enormous amounts of material, will cause Earth's orbit to drift outward just enough to survive. Survive meaning a scorched, airless, waterless, magma-surfaced rock orbiting inside a red giant's outer atmosphere, dragged by tidal friction, its day growing shorter as it spirals. Not survival in any meaningful sense. Mars escapes the swallowing. But Mars, which is already cold and thin-aired, will experience something it has not seen in billions of years. The red giant's heat, even from Mars's distance, will be enough to melt its polar ice caps. For a brief window, brief by cosmic standards, perhaps 1,000,000 years, liquid water might flow on Mars again. The planet that may have once harbored life, dead for billions of years, will experience a short, brutal second spring. And then that too will end, as the sun's outer layers continue to drift away. Jupiter, Saturn, Uranus, Neptune, the outer planets survive structurally. Their cores persist, but the bombardment of radiation and particles from the dying sun will strip their outer atmospheres in ways we do not yet fully understand. The gas giants may not remain as gas giants. Some models suggest Jupiter loses a significant fraction of its mass. What that leaves is something our instruments have never seen up close. The gut punch moment is this. After the red giant phase, the sun ejects its outer layers entirely, a slow explosion of gas and plasma called a planetary nebula, which is a terrible name because it has nothing to do with planets. It is the star's own body scattered into space. What remains at the center is the core, a white dwarf, an object roughly the size of Earth, but with roughly half the sun's current mass, so dense that a teaspoon of its material would weigh 5 tons here on Earth's surface. The white dwarf does not burn. It does not fuse. It simply glows with residual heat, the way a coal glows after the fire is out. And it cools. Over billions of years it cools, and the current age of the universe, 13.8 billion years, is not long enough for any white dwarf that has ever existed to have cooled completely. They are all still glowing, faintly. Eventually, in a time so vast it has no human scale, they cool to black. They become what astronomers call black dwarfs, objects that emit no light, no heat, no radiation of any detectable kind, a cold, dark remnant of something that once lit 8 planets. No black dwarf is known to exist yet. The universe has not been around long enough, but it is coming. Here is where the numbers stop being useful. You can be told that 5 billion years is the timeline. You can be told that the sun will swell to 200 times its size, that Mercury and Venus and possibly Earth will be absorbed into the expanding star, that the solar system will eventually orbit a cooling white dwarf in permanent silence. You can hold all of those facts in your mind simultaneously and still not feel them, because the human brain did not evolve to feel 5 billion years. It evolved to feel next winter, to feel whether the rain is coming, to feel whether the animal in the tall grass is going to charge. We are wired for the immediate, the personal, the graspable. We are wired to care about things that happen to us, to people we can name, to places we can picture. This is not a flaw. This is the reason you are here, reading this. Because every ancestor you have ever had was good at surviving the immediate. They made it through the next winter, and the next, and the next. But there is a version of being human that reaches beyond the immediate. That looks at a fact it cannot feel and sits with it anyway. That lets the numbers work on it slowly, the way water works on stone. 5 billion years ago, the sun did not exist. Neither did Earth. Neither did anything recognizable. The atoms that make up your body, the carbon, the oxygen, the iron in your blood, were forged in stars that lived and died before the sun was born. You are not just a passenger in this solar system. You are, in a very literal sense, made from previous endings. Every death in the universe is also a distribution of material. The planetary nebula that the sun becomes will expand into the interstellar medium. Its material, oxygen, carbon, nitrogen, will drift and cool and eventually fall into new regions of gas and dust that are already beginning to collapse somewhere in this galaxy. new stars will form from it, new planets, new chemistry. Whether any of that chemistry leads to something that can wonder about its own origin, that is the question science cannot currently answer. But the chemistry itself is not speculation. That is what happens. That is what has always happened. The Sun is not an exception. It is approximately the 10 billionth star of its type to complete this cycle in this galaxy alone. Before the Sun, countless others went through the same sequence: ignition, main sequence, expansion, collapse, remnant. Their remnants seeded the cloud that became the Sun. The Sun will seed something else in turn. That is the mechanism. That is the machine. And inside this machine, on a small world third from one star of 200 billion, a species has existed for roughly 300,000 years. In the Sun's total lifespan of 10 billion years, that is 3 seconds on a 24-hour clock. 3 seconds in which a species went from stone tools to radio telescopes, from burning wood to decoding the nuclear physics of stars. 3 seconds. In those 3 seconds, we named the stars. We calculated the orbits of planets we could not yet see. We sent small metal machines to the edges of the solar system and listened to the signals they sent back across billions of miles of empty space. We figured out how the Sun works, not by guessing, but by building the mathematics of nuclear physics from scratch, and then testing it again, until the predictions matched the observations with a precision that leaves almost no room for doubt. We know how the Sun will die because we understand it, not perfectly, not completely, but well enough to say with confidence, here is the sequence, here is the timeline, here is what happens to the planets one by one. That is an extraordinary thing for 3 seconds of existence to produce. The Sun does not know we are here. It is not keeping track. It will expand and consume and collapse and cool without reference to anything we have built or thought or named. The universe does not pause for the things it created. It does not register their wonder. It simply continues. And yet, the wondering happens. The naming happens. This conversation is happening. Somewhere in the long, slow mechanism of stellar evolution, a small animal looked up and thought, I want to understand that, and started counting. The light on your face is 8 minutes old. It has 5 billion years left. Use yours well.